Something strange is happening in the quiet corridors of space. Beyond Mars, past the orbit of Jupiter, an object is drifting through the darkness alone. It's not just any object. It's called 3I Atlas, the third confirmed visitor from another star system. And right now, it's moving toward us. Before we go deeper, take a deep breath, because tonight we'll drift through the void together, unraveling one of the strangest mysteries in our solar system. And if you enjoy stories that make you look up at the sky with wonder, don't forget to subscribe, so you never miss what's truly happening above our heads. Now, let's begin. Imagine the silence of space, a silence so complete that even the stars seem to whisper. Out there, somewhere between Mars and Jupiter, a cold traveler sails through the main asteroid belt. Its path cuts clean through billions of rocks, tiny fragments of worlds that never formed. Yet this one is different. Scientists call it 3I Atlas. Not a comet, not an asteroid, something in between. An interstellar visitor, an object from beyond our sun day. It's moving fast, 60 kilometers per second. That's more than 200,000 kilometers every hour, faster than anything humans have ever built. And it's not just passing through casually. It's slicing through space in a hyperbolic orbit, one that doesn't belong to our solar system at all. Its origin, the direction of Sagittarius, the constellation that points toward the center of the Milky Way, where stars are packed so tightly that light struggles to escape their gravity. That's where this object came from. At least, that's what the math tells us. But here's the question that keeps astronomers awake at night. What exactly is 3I Atlas? Some believe it's just a fractured piece of rock torn apart from a planet long ago, maybe from a red dwarf star system, a small dense star where gravity pulls so tight that even a planet could crack and crumble. And perhaps one of those fragments was thrown into space with incredible force until it drifted across the cosmic sea and ended up here in our neighborhood. Others think it could be something far stranger, because this isn't the first visitor from another world. We've had two before. First came Oumuamua in 2017, a long, cigar-shaped mystery that tumbled through our solar system with no clear explanation. Then came Borisov, a more traditional-looking comet, but still not from here. And now, our third 3I Atlas, larger, slower, and surrounded by something scientists can't quite explain. You see, when telescopes first locked onto it, 3I Atlas appeared shrouded in a cloud, a glowing sphere of gas, dust, and plasma, stretching nearly 700,000 kilometers across. That's half the size of our Sunday, half the size of the sun, for a single moving object. Yet the object itself, the core, or what we call the nucleus, is only estimated to be somewhere between 1 and 50 kilometers wide. That's like hiding a mountain inside a mist the size of a star. And still, no telescope has seen the core directly. It remains hidden behind layers of carbon dioxide, frozen dust, and glowing gas. When light hits this haze, it scatters, creating that strange ghostly glow we see in images, almost like it's alive. August 27th, 2025. The Gemini South telescope captures a breathtaking image. Through its massive mirrors, the object appears as a hazy sphere, beginning to stretch, forming the faint trace of a tail. Comets form tails when the sun's warmth causes their frozen surfaces to sublimate, turning ice into gas and gas into a trail of shimmering particles. But 3I Atlas was still far from the Sunday, too far for such reactions. So what was heating it? Could it be radiation from cosmic rays? Electromagnetic interaction? Or something else entirely? Something we still can't measure? For now, scientists only know one thing: it's changing. In early October, 3I Atlas reaches its closest approach to Mars. From our point of view, it's speeding past the red planet, quiet, distant, yet dangerously close in cosmic terms. If it were an artificial craft, this would be the moment to deploy. Some people online started whispering theories. Was it alien technology? A probe? A drifting vessel from a civilization that collapsed long ago? Of course, no one knows. But when something this large, this fast, and this unexplainable enters our solar system, curiosity is inevitable. The strange part is not just that it's passing near Mars, it's the path it's taking. Unlike most comets that soar above or below the plane of the solar system, 3I Atlas's orbit is tilted only about 5 degrees off. That means it's cutting right through the middle, right through the main asteroid belt. Billions of rocks, tiny worlds, each moving in its own quiet orbit. And this interstellar visitor, this glowing wanderer, is slicing right through the heart of it all. Now, think about this for a second. When we send our own space probes through the asteroid belt, the chance of them hitting something is roughly 1 in a billion. That's how vast and empty space really is. But 3I Atlas is much larger than a probe. It has its own gravity, its own electromagnetic field, and perhaps even something more. So yes, the odds are still tiny, but not zero. A collision, even the smallest one, could change everything. Let's pause here for a moment. Imagine that an interstellar object traveling 60 kilometers per second crashing into an asteroid. The explosion would release more energy than any bomb humanity has ever made. It would scatter debris across millions of kilometers of space and redirect the object's course entirely. It could send it into a new orbit, maybe even toward the inner solar system, toward Earth. And yet, nobody knows if anyone's running the numbers. There's been no official simulation, no global statement. No supercomputer has publicly mapped every possible collision point. It's as if the world isn't paying attention. What makes this so curious is that the asteroid belt isn't just a random pile of rock. It's a living system, electrically charged, magnetically alive. Billions of particles interacting with the sun's energy, creating invisible filaments of electromagnetic current. Scientists call it a complex dusty plasma. And right now, 3I Atlas is flying straight through it. When sunlight hits the dust of space, it charges particles, making them dance in invisible fields. Each asteroid, no matter how small, has its own electric potential, its own invisible bubble. When one of these bubbles interacts with another, tiny currents form currents that shape the entire region of space. Now imagine introducing a visitor into that delicate balance. A visitor surrounded by a half-solar diameter cloud of gas and plasma. That's what's happening right now. 3I Atlas is stirring the cosmic dust. Electric forces swirl around it. Invisible magnetic threads twist and stretch in response, and somewhere deep within that haze, something unpredictable is happening. You might be wondering, why does any of this matter? Because every time something passes through our solar system, it changes it. It stirs the plasma winds. It warps the magnetic field lines that flow between planets. It can even strengthen the interplanetary magnetic field, the same one that protects Earth from radiation. And if the timing is just right, if solar activity spikes while this object sweeps past, those charged dust clouds could travel inward toward our world. They could trigger intense auroras, geomagnetic storms, and possibly affect satellites or communication systems, all from a fragment of another world, just passing by. Still awake? Good. Because this story only gets stranger from here. Every object in the asteroid belt, from the smallest pebble to the dwarf planet Ceres, has a role to play in the cosmic dance. Some of those objects came from beyond Neptune, trans-Neptunian bodies that migrated inward long ago. They're icy, volatile, and fragile. They shed gas when sunlight touches them, filling the belt with more and more dust. And that's where 3I Atlas is traveling. Through a glowing, invisible sea of charged dust grains, each one reacting to solar wind and magnetic current. To move through this region is like gliding through a storm of energy. You can't see it, but it's there. Every tiny particle pulling and pushing against the visitor's halo, like the ocean against the hull of a ship. At this point in the journey, scientists are still watching, still trying to understand what's going on inside that enormous cloud. They know it's not behaving like a normal comet. It's not producing clear jets or structured tails. It's coma. That vast glowing envelope is too large, too calm, and somehow too symmetrical. It's as if something inside is maintaining its shape, as if there's balance, control. And that, more than anything, is what has everyone talking. So, what if it's not just nature? What if something or someone built it? That's the question no one dares to ask officially, but you'll find it whispered across countless online forums. If it is artificial, then the asteroid belt would be the perfect hiding place. A graveyard of rocks, a camouflage field of debris, an endless cover from prying eyes. After all, if an advanced civilization wanted to study a developing species, they wouldn't park a glowing ship near Earth. They'd place it somewhere quiet, somewhere overlooked, like the asteroid belt. Right now, 3I Atlas is on course for what's called superior conjunction, a straight alignment of Earth, the Sun, and the object behind it. That'll happen around October 21st. During that period, it will be nearly invisible from Earth. hidden in the sun's glare. No telescope will be able to see it clearly, and that's when we'll learn the most. Because if it behaves like a comet, we'll see jets, streaks, and outgassing, signs of natural chemistry. But if it doesn't, if it stays strangely uniform, steady, balanced, then maybe it's not a comet at all. For now, the world waits. The sky looks calm, but above us, an ancient traveler is cutting through cosmic dust, a silent messenger from another star. Its path uncertain, its story untold, and we are just beginning to listen. The stars are still, but deep within the main asteroid belt, something vast is moving. 3i Atlas, that cold, glowing traveler, still drifting through space, surrounded by its misty halo, half the size of the sun itself. And though the world below sleeps, somewhere on Earth, telescopes are still awake, watching. In the quiet control rooms of observatories, glowing monitors trace its motion pixel by pixel. A green line across a digital map, one curve that doesn't belong to anything known. Scientists zoom in, zoom out, double check. Every number matters now, because the smallest miscalculation could mean everything. You see, space isn't empty. Between Mars and Jupiter lies a sea of motion, billions of silent stones circling the sun. Each rock, each grain of dust carries its own orbit, its own gravity, its own ancient story. And now, into that crowded ocean, sails a visitor from another star. No wonder astronomers can't sleep. When 3i Atlas entered this region, they expected nothing unusual, just another comet passing through. But instead of fading quietly, it began to glow brighter, not like a flash, not like a typical burst of sublimation, but more like a pulse, slow, rhythmic, almost alive. Every few hours, telescopes detected subtle fluctuations in brightness, as if something beneath that dusty coma was spinning, rotating, breathing light into space. Was it a tumbling rock? Or something turning deliberately? No one could say. By late September, spectroscopic data revealed strange readings, unusual ratios of carbon dioxide and metallic ions, patterns that didn't quite fit any known comet composition. There were traces of materials that seemed refined, almost too pure. That's when the whispers began again. Could it be artificial? Maybe it's an ancient fragment of a destroyed world. Or, as one scientist quietly wrote in his notes, if this object is technological, it's not signaling us, it's observing. The possibility of contact, even indirect, sends a chill through the astronomy community, because the idea of something built beyond our solar system, now passing right through it, challenges everything we know about life and distance. But there's another possibility, one far less comforting. Maybe 3i Atlas is simply old. Older than our Sunday, older than Earth itself. A fragment from a dead system that burned out billions of years ago, still carrying the chemical fingerprint of its birth star. A red dwarf that once held a shattered planet in its orbit. If that's true, then what we're watching isn't a machine. It's a ghost, a frozen piece of a world that once was, sailing forever through the dark. Still, the danger remains, because even ghosts can collide. Astronomers began running simulations, thousands of them. They tried to predict how close 3-eye atlas would come to any known asteroid. The results were comforting at first. No confirmed collision courses, no catastrophic encounters. But those models only included the biggest 20 asteroids, the ones large enough to name and track. There are millions of smaller ones unaccounted for. And when you add them to the equation, things get complicated. A single invisible rock, only a few hundred meters wide, could be enough to shatter the visitor's coma, scatter its dust, and alter its trajectory forever. The probability is tiny but not zero. And when it comes to space, not zero means eventually. Let's slow down here for a moment. Picture this. You're standing in a vast, dark ocean. Waves stretch endlessly in every direction. You can't see the shore. You can barely see your hands. Now imagine throwing a single pebble into that sea and trying to guess where it will land. That's what predicting collisions in the asteroid belt is like. Every object pulls on every other object. Gravity bends paths. Light pressure nudges orbits. And electromagnetic forces twist trajectories like threads in a storm. So when 3-eye atlas entered the belt, it didn't just pass through, it began to interact. The sun's radiation charged its massive coma. It collected electrons, positive ions, dust. It became an electromagnetic creature, a moving, breathing field of plasma. And space already filled with dust and currents responded. The whole region began to shimmer subtly. Tiny shifts in brightness were seen in nearby asteroids, as if their surfaces were reflecting more light than before. Something was happening out there. Something invisible, but real. If you could drift beside it, if you could hover silently in the black, watching the object glide past the distant sun, you would see a slow ballet of forces at work. Tiny streams of dust levitating in place, charged grains orbiting like miniature moons, magnetic arcs glowing faintly in ultraviolet. It would look almost alive, like a giant glowing jellyfish swimming through the solar wind. And every so often, you'd feel a pulse, a faint vibration in the fabric of space itself, an electrical hum, like the echo of a far-off storm. On Earth, those pulses are invisible to human eyes, but space weather sensors sometimes pick up faint anomalies, tiny fluctuations in solar wind speed, in the magnetic field strength near Earth's orbit. Nothing dramatic, just unusual. Could it be connected or just coincidence? Scientists debate quietly. Nobody wants to sound alarmist. But in private, some admit there's something synchronized about the pattern, as if the object is resonating with the sun's electromagnetic rhythm. And that is new. Around this time, a few independent observers noticed another oddity. The coma of 3-eye atlas, which had been soft and circular for weeks, began to flatten slightly, almost like a disk. In long exposure images, its edges looked sharper. The light wasn't diffusing evenly anymore. Some parts seemed reflective, metallic even. Telescopes from Hawaii to Chile confirmed it. The shape was changing, but why? Some said it was simply solar wind pressure. Others suspected rotation. And a few whispered theories far more unsettling, that something inside was adjusting, perhaps maneuvering. Whatever the truth, October approached, the month of superior conjunction. From our perspective on Earth, the object was about to slip behind the Sunday, invisible, unreachable. For weeks, it would vanish completely from human observation. Astronomers prepared for silence, a cosmic blackout. If anything happened during that time, if it changed direction, broke apart, or accelerated, we wouldn't know. Not until it reappeared on the other side. And so began the long wait. October 18th, the last visible glimpse before conjunction. Telescopes captured faint streaks of light, the tail now more pronounced, stretching gently away from the Sunday. Still no jets, no violent bursts, just a quiet, elegant stream. Then it was gone. Swallowed by the sun's glare, the world moved on. News cycles shifted, but a handful of scientists kept their eyes on the data, monitoring the solar wind, magnetic readings, anything that might hint at what was happening behind that burning curtain of light. And then something changed. On October 22nd, just one day after conjunction, the solar wind near Earth suddenly strengthened. Not a massive solar storm, but a strange pause, a perfectly timed surge in interplanetary magnetic field strength. It lasted for hours, enough to cause subtle radio interference, enough to register on magnetometers around the globe. Coincidence? Maybe. But the timing was perfect. Somewhere behind the sun, 3I Atlas was still moving, and the sun itself seemed to respond. In the days that followed, the Earth's upper atmosphere shimmered with faint auroras, even at latitudes where they're rarely seen. Soft green waves over skies that should have been dark. It wasn't enough to raise alarms, but it was enough to make people look up and wonder. And that's when the theories exploded online. Some said it was proof of electromagnetic interaction. Others claimed it was debris colliding, sending charged dust inward toward the Sunday. And a few, of course, suggested the unthinkable, that something out there had activated. For now, all we know is this. 3I Atlas survived its passage through the asteroid belt. No visible collisions, no fragmentation. It passed clean through, untouched, unchanged. Or at least, that's what it looked like. But appearances can be deceiving, because in every simulation that predicted its motion, scientists assumed one thing, that it would stay on a perfect hyperbolic trajectory, unaffected by external forces. But if its electromagnetic field interacted even slightly with the dust and plasma of the asteroid belt, its orbit could have shifted, maybe by only a fraction of a degree. But in space, a fraction of a degree can mean everything. That's all it would take to change its future path. Now, let's think bigger. Let's imagine that instead of flying harmlessly out of the solar system, its path bent ever so slightly inward. Not enough to notice yet, but enough to matter months from now. What happens if that shift lines up with Earth's orbit? What if, by pure cosmic chance, we're standing in the path of a traveler from another star, one that's been drifting for billions of years and is now heading home through us? It sounds impossible. But so did the idea of interstellar visitors until they showed up. Space doesn't make mistakes. It just follows the math. And right now, the math says we're dealing with something unpredictable. Something that doesn't behave like anything we've seen before. Something that might be natural or not. And while scientists are cautious, one truth hangs heavy in the air. We're not prepared for surprises from the stars. In the next segment, we'll explore what happens if 3I Atlas doesn't leave, if it slows down, or changes course, or breaks apart near the sun, and what that could mean for Earth's magnetic field, our skies, and perhaps our understanding of what or who might be watching. The days after conjunction felt quiet, too quiet, when the sun finally drifted far enough for telescopes to search again. Astronomers expected to find their glowing wanderer right where the charts predict. But when the first images arrived, there was a pause. 3I Atlas was there, but something was different. The tail that once stretched faintly behind it was gone. In its place was a narrow beam of light, sharp, clean, and almost vertical to its previous direction. It looked deliberate. At first, many assumed the cameras glitched or that sunlight was scattering oddly through the atmosphere. But other observatories confirmed the same thing. 3I Atlas had changed. When they compared its new position to the last recorded one before conjunction, there was a shift, tiny but unmistakable. Not a drift caused by gravity, not a random nudge from dust or gas, a turn, only a fraction of a degree, but that tiny angle meant that the object's new path no longer matched the models. If the change continued, it would curve slightly inward toward the inner planets. The official statement was cautious. Words like data refinement and measurement uncertainty filled the report. But between scientists, a quiet alarm spread. Because objects from other stars aren't supposed to turn. Not like that. For now, they called it a non-gravitational acceleration. That's the polite term astronomers use when something moves in a way they can't explain. Oumuamua did it too. As if a subtle pressure was pushing it, but without a visible source. Maybe sunlight was doing it. Maybe jets of gas invisible to our senses. Or maybe, and no one said this out loud at first, something else was guiding it. Night after night, telescopes followed the trail. Each observation showed the same slow curve, barely perceptible but steady. And along with that shift came another mystery. The light itself was pulsing again, this time in a pattern, a slow rise, then fall, exactly every 11 hours, over and over. Rotation, perhaps? Or a signal? No one dared to call it communication. But the rhythm was unnerving, too consistent to ignore. Meanwhile, the sun grew restless. Massive flares erupted from its surface, coronal ejections streaking outward like fiery ribbons. The solar wind thickened, its stream of charged particles roaring across space. And at the same time, the magnetic readings around Earth began to spike. Compasses wavered. Radio waves hissed faintly with static. Not enough to panic anyone, but enough to make scientists stare at their graphs in disbelief. Because the timing was perfect, again, every surge from the sun seemed to echo the pulse of 3I Atlas, as if the visitor and the star were whispering to each other through fields of energy. Imagine it for a moment. Two enormous forces, the sun blazing with plasma and magnetism, and an interstellar traveler wrapped in his own electric shell, meeting in the emptiness between worlds. Invisible currents flowing, dust glowing like fireflies, and somewhere within that radiant chaos, a silent dance of energy unfolding. No one on Earth could see it directly, but the sensors did, the data did, and the story those numbers told was both beautiful and terrifying. By late October, the visitor reached perihelion, its closest approach to the Sunday. Roughly the same distance as Venus, but far hotter than anything it had endured before. If it were ice, it should have boiled away. If it were rock, it should have cracked and vaporized at the edges. But 3I Atlas remained steady. No violent fragmentation, no collapse of the coma, only that quiet glow, stronger than before. It was as if the heat was feeding it, not destroying it. Down on Earth, ordinary people knew nothing of this. The sky looked normal, but high above, satellites began to register interference. GPS signals flickered. One communication satellite briefly lost orientation. Engineers blamed solar activity, and they were right, partly. But a handful of scientists noticed that the disturbances formed a pattern, the same 11-hour rhythm that matched the pulses of the interstellar object. Coincidence again? Perhaps, but the odds were shrinking with every rotation. Then came the flare. October 29th, the day of perihelion. At precisely the moment 3I Atlas aligned closest to the Sun, a massive X-class solar flare erupted from the solar surface. It hurled a cloud of plasma millions of kilometers wide, and when scientists later traced the trajectory, they realized the flare's direction lined up almost perfectly with the object's position. Space isn't supposed to aim like that. The Sun doesn't choose targets, but the alignment was exact. For a few minutes, radio telescopes captured strange emissions, frequencies that didn't match typical solar signatures. Short bursts, repeating intervals, almost like echoes, and then silence. When the brightness cleared, 3I Atlas was still there, brighter than before. Its coma now stretched wider than ever, nearly 1 million kilometers across. Whatever the Sun had thrown at it, the object had absorbed. Scientists watched, speechless, as the visitor seemed to shimmer, its glow fluctuating in deep reds and blues, colors rarely seen in comet tails. Plasma analysis later showed traces of ionized iron and nickel, metals that require enormous heat to vaporize, meaning somewhere within that halo, metal was melting and reforming. How? No one could say. In the following days, it began to slow. Not much, just a tiny decrease in velocity, but it was enough to notice. Objects on hyperbolic orbits don't slow down. They accelerate as they fall toward the Sun, then sling outward, gaining speed as they escape. Yet this one wasn't behaving that way. It was as if something inside was breaking, using energy we couldn't detect. By mid-November, its velocity had dropped by almost 2%. That might not sound like much, but in cosmic terms, it was huge. It meant one thing. Its orbit was no longer an open curve. It was closing. If the trend continued, 3I Atlas wouldn't leave the solar system at all. it would stay captured. At this point, theories multiplied. Some scientists suggested electromagnetic drag, interactions between the object's plasma cloud and the sun's magnetic field. Others proposed an unknown composition, something dense enough to resist heat but responsive to magnetic pressure. And, of course, the most controversial idea of all, that it was controlled. If it could alter its speed deliberately, then it might be adjusting its trajectory intentionally, perhaps to settle into a stable orbit. And if that orbit lay inside the asteroid belt, then it might remain here, circling quietly among the rocks, forever hidden between Mars and Jupiter. Publicly, space agencies avoided speculation, but leaked internal memos revealed that emergency observation schedules were drafted. New telescope time was requested. Radar experiments were planned. The object was now officially labeled a priority target. Meanwhile, amateurs around the world turned their cameras to the heavens, searching for any trace of movement. Many found nothing. Some swore they saw flickers, tiny flashes, repeating in sequences, as if the object was blinking in coded light. A pattern of 3 short bursts, then 1 long, again and again. Coincidence or design? On November 10th, a team in Chile released an updated orbital plot. It showed something unprecedented. The visitor's path intersected the orbital plane of Earth, not soon, but months from now. If the deceleration continued, its new trajectory would cross our orbit near July of the following year. The words collision course were never used. Instead, the report simply read, potential orbital intersection, low probability, further monitoring required. But that phrase, low probability, did little to calm anyone who understood what it meant, because the probabilities were based on incomplete physics, and 3i Atlas was rewriting those physics day by day. Let's slow down here. Close your eyes. If you're listening to this at night, picture that glowing sphere again, drifting through the blackness. A tiny star that isn't a star, wrapped in silence older than time. Somewhere inside that luminous shell, a solid core spins. Maybe a fragment of stone, maybe something hollow, maybe something alive. Whatever it is, it's moving slower now. It's adjusting, choosing its place in the solar system. And perhaps, just perhaps, it's watching. There's a saying among astronomers, everything that falls into sunlight tells us who we are, because sunlight is the great revealer. It strips away illusions, burns off shadows, exposes truth. But in this case, the light only deepened the mystery. The more we observed, the less we understood. Why didn't it vaporize? Why did it slow down? Why did its brightness pulse with the rhythm of the sun? And above all, why now? Of all the ages, of all the moments in cosmic history, why does a visitor from another star arrive? At the very time humanity begins reaching into space, coincidence or timing? By late November, whispers turned to quiet dread. In online forums and late-night radio shows, people speculated that the object had changed course toward Earth. No evidence yet, but fear doesn't need evidence. Astronomers urged calm. They explained probabilities, orbital mechanics, statistics, so small they seemed absurd. 1 in a billion, 1 in 10 billion. But the human mind doesn't feel numbers. It feels possibility. And even 1 in 10 billion is still 1. Meanwhile, something else began happening. Earth's ionosphere, the layer of charged particles high above us, started resonating faintly in frequencies that matched those 11-hour pulses. Satellites detected it first. Then ground stations confirmed. It was subtle, barely measurable. But it was there. Some researchers called it a coupling effect, energy from solar winds resonating with Earth's magnetic field. But the timing was uncanny. Each pulse from 3I Atlas seemed to ripple outward through the solar wind, through the heliosphere, until it brushed the edge of our planet's invisible shield, a whisper across the void. By December, one thing was clear. 3I Atlas was not leaving anytime soon. Its new orbit, though uncertain, looked increasingly bound. For the first time in human history, we might be witnessing the capture of an interstellar object, a piece of another world, or something pretending to be one, becoming part of our own, and that realization changed everything. In the next segment, we'll enter the climax. The moment when the object's path crosses the orbit of Earth, where the smallest shift could mean disaster or revelation. We'll explore what scientists fear most and what they hope to discover as 3I Atlas slows, turns, and perhaps begins to speak. The calendar turned quietly into December. The nights grew longer, and the cold winds swept across the deserts where telescopes stood like silent giants. Inside those domes, scientists watched the same blinking point of light, night after night, the distant traveler that refused to behave, 3I Atlas, the interstellar guest that came without invitation and now seemed in no hurry to leave. By now, the object's path had flattened into a graceful curve around the Sunday. It was no longer rushing out of the solar system like a stone from a sling. It was orbiting a perfect arc, delicate, smooth, and eerily precise. Too precise for chance. If it had been a comet, it should have fragmented by now. If it had been an asteroid, its surface should have melted or cracked. Instead, it remained stable, glowing softly against the black. And with each passing day, its new orbital path edged a little closer to Earth. When the first global simulation models included the latest readings, a quiet murmur spread through the astrophysics community. The object wasn't on a direct collision course, not yet, but its future intersection with Earth's orbit was confirmed. That meant that someday soon, Earth and 3I Atlas would share the same region of space. Perhaps not at the same time, but close enough that it would pass within a few million kilometers. That's cosmic breathing distance, barely an eyelash across the face of infinity. For now, there was no cause for alarm. At least, that's what the officials said. But behind the scenes, preparations began. Observatories recalibrated instruments to record high-energy radiation. Deep space tracking networks extended their watch zones. Even amateur astronomers were invited to gather light curve data. The world wasn't panicking. It was listening, waiting, watching the skies for a glow that grew brighter each night. December 15. Images from the James Webb Space Telescope showed the coma glowing faintly in the infrared spectrum. Too warm for a mere dust cloud. It was radiating heat, consistent, even warmth, like something maintaining its own temperature. That discovery changed everything. Objects in deep space don't stay warm unless something inside them produces energy. Radioactive decay, perhaps, or friction from motion, or something else entirely, something we've never seen before. A small team from the European Space Agency proposed a daring mission. They called it Project Lysithea, a plan to launch a fast probe, intercept the object near its next perihelion, and analyze it directly. But that would take time, and 3i Atlas wasn't waiting. Every projection showed it passing within the orbit of Earth by mid-year. If its current speed held, we'd see it with the naked eye by early summer, a glowing streak that might outshine Venus. And if it slowed even more, then we might see something else. As the days passed, the magnetic resonance between the object and the sun intensified. Solar wind streams began forming organized, spiral-like patterns. Even the heliospheric current sheet, the vast, wavy plane of electrical flow that fills the solar system, started showing distortions. It was as if the entire heliosphere, the bubble of plasma that protects our solar system from galactic radiation, was flexing. Earth's magnetosphere, in turn, responded with shimmering auroras seen farther south than ever before, over Nigeria, over Italy, over deserts and oceans that had never known green skies. It was beautiful and deeply unsettling. In those green-lit nights, people took photos, posted them online, and wrote captions like, "Looks like the heavens are awake." But few realized that the cause of that light was drifting through the void, halfway between Mars and the Sun, and it was heading inward. Back in the laboratories, scientists began noticing one more anomaly. Radio silence wasn't silence anymore. Across multiple frequencies, deep space receivers picked up faint modulations, bursts repeating at uneven intervals, embedded within natural background noise. They weren't strong enough to decode. They weren't random enough to ignore. When analysts plotted them over time, they formed a shape, a rising curve, a sharp drop, and then a steady plateau. Not a signal in the traditional sense, more like a heartbeat. Some thought it might be internal resonance from ionized gas. Others weren't so sure because the same rhythm aligned perfectly with the object's rotation period. Around December 30th, the world entered a strange rhythm of its own. Holiday lights on Earth twinkled beneath auroras, while high above, a glow barely visible to human eyes inched closer every day. 3i Atlas was now a fixture in the data streams, satellites tracking the sun, instruments measuring radiation, even cosmic ray detectors on the International Space Station. All recorded irregularities that matched its pattern. It was no longer just a visitor. It was part of the system. Then came the flare storm, January 2nd. A massive burst from the sun erupted directly toward the object. For 2 days, solar radiation battered its coma. If it were a normal comet, it would have disintegrated instantly. Instead, the opposite happened. The object brightened, it absorbed the energy, and then released it gradually, like a slow exhale. Its coma expanded again, becoming perfectly spherical. For the first time, spectrographs detected a pattern in its radiation, not chaotic, but ordered. The emissions followed mathematical ratios, ones identical to magnetic field harmonics. It was as if it was using the sun's own energy to create equilibrium. On Earth, instruments went wild. Some satellite gyros began oscillating in sync with those ratios. Power grids in the far north experienced brief fluctuations, not destructive, but synchronized. The planet itself seemed to hum faintly in rhythm. When magnetometers from multiple continents compared results, they realized the same periodic oscillation appeared everywhere, the same 11-hour cycle. Whatever this object was doing, it was reaching us. For the first time, governments held a private joint session between major space agencies, NASA, ESA, JAXA, and others, quietly shared data that had never been released to the public. What they saw was impossible to ignore. The object's orbit had stabilized into a new elliptical path that would bring it as close to Earth as 24 million kilometers, roughly 0.16 astronomical units. In early July, that's closer than any interstellar object had ever come, too close to dismiss, and the world, though still calm, was about to witness it with their own eyes. Through January and February, 3I Atlas grew brighter. Photographers from Chile, Arizona, South Africa, all captured faint blue hues appearing around it. Its color wasn't the usual icy white or green of comets. It was electric blue, like ionized oxygen under a magnetic arc. Some frames even showed faint filaments, threads of plasma stretching behind it, like wings. One image, briefly released before being removed from the agency server, showed a symmetrical cross pattern within the coma, as though 4 concentrated beams of light were forming a geometric lattice. The official explanation? Camera diffraction. But many disagreed. Whatever it was, it looked engineered. Scientists hesitated to speak openly. Words like artificial carried weight. They could destroy careers. So they spoke carefully. They called it structured energy dispersion. They called it coherent magnetic resonance. But behind those technical phrases was something far more human: wonder and fear. Late February, a quiet, bright morning in South America. A telescope in the Atacama Desert detected a brief, direct radio reflection from the object, as though it had mirrored an incoming signal back to Earth. The frequency matched a routine radar ping used for asteroid tracking, but the reflection came back amplified, clean, too clean, almost as if it understood. If you were standing outside that night, you wouldn't have noticed anything unusual, just a few extra stars glittering softly above. But to those watching through their screens, the data told a different story. 3I Atlas was no longer drifting. It was holding, suspended in an orbit between Mars and Earth, almost perfectly stable, like it was waiting. Waiting for what? No one could say. Back on Earth, some scientists argued that it was natural, a rare alignment of gravity and electromagnetic pressure. Others believed that explanation was too neat, too comfortable, because nature doesn't pause. Nature doesn't hold its breath, and yet space itself felt still. The solar wind calmed. The background radiation dipped slightly. Even the cosmic noise that fills every radio telescope fell quiet. It was as though the universe was listening too. In the coming months, the object would draw closer. We would soon see it without telescopes. A blue-white light crossing the twilight sky. Children would point to it from rooftops. News channels would call it the cosmic lantern. And poets would write about it, thinking it was just another comet. But those who had watched since the beginning knew it was not just a comet. It was something else, something ancient, something deliberate, something that had now become part of our story. In the next segment, we'll enter segment 5, where 3i Atlas reaches its closest point to Earth, and the world finally sees it with their own eyes. We'll explore what happens when its presence begins to affect our atmosphere, our technology, and maybe even our consciousness itself. March arrived quietly. The object that once seemed distant beyond imagination was now officially within the orbital region of Earth. Not near, not yet visible to the naked eye, but scientifically speaking, it had entered our neighborhood. 3i Atlas continued to travel at roughly 58 kilometers per second, still extraordinarily fast, but slower than before its solar encounter. That slight deceleration remained unexplained. The data was precise. It showed a continuous reduction in speed, measured by Doppler shifts in reflected light. The deceleration was uniform, not chaotic, not random, exactly proportional to the intensity of solar wind pressure at each observation point. That was the first anomaly, because solar wind, though powerful, cannot slow an object that massive in such a clean, consistent way. Something was compensating. Something was balancing external forces with internal control. By mid-March, researchers noticed a new effect. Light curves taken at different wavelengths no longer matched simple scattering models. When the object rotated, its brightness fluctuated across specific spectral bands, as if different regions emitted energy independently. Infrared sensors registered intermittent pulses, thermal emissions that did not correspond to solar heating. They were too regular, too narrow in bandwidth, like heat being generated rhythmically from within. That meant one of two things. Either the interior contained isotopes undergoing controlled decay, or it was converting electromagnetic energy directly into heat. Both options were equally strange. The plasma surrounding 3i Atlas also began to change. It was no longer a smooth coma. High-resolution imagery revealed concentric shells, thin, wave-like layers radiating outward. Each shell expanded at measurable intervals, like ripples on the surface of water. Every 33 hours, a new wave would emerge, move outward at approximately 30 kilometers per second, and gradually dissipate. The consistency was unsettling. It suggested periodic discharge, possibly electromagnetic. One physicist described it quietly as a natural antenna the size of a small planet. If that was true, then 3i Atlas wasn't merely reacting to sunlight, it was interacting with the entire heliospheric field, absorbing energy, storing it, and releasing it in measured cycles. By April, spacecraft across the inner solar system began recording side effects. The Parker Solar Probe, orbiting near the Sun, registered localized fluctuations in magnetic flux density, precisely synchronized with those ripple emissions even at distances of tens of millions of kilometers. The effect was measurable. The solar orbiter detected similar patterns, ion density oscillations matching the object's emission rhythm. For the first time, scientists realized that the visitor wasn't just influencing the space around it. It was influencing space itself, shaping the behavior of charged particles in the solar wind. That discovery marked a turning point. The conversation shifted from astronomy to plasma physics to magnetohydrodynamics and eventually to controlled electromagnetic systems. Still, there was resistance. No one wanted to claim intelligence or control. So the working theory became this: electromagnetic self-stabilization. In simpler terms, the object was thought to have developed a plasma sheath so responsive to external fields that it effectively acted as a dynamic sail, using the sun's energy to maneuver. Nature could, in theory, produce such behavior. If the composition was right, perhaps a metallic core coated in volatile compounds, capable of ionizing when exposed to solar radiation. But even that didn't explain the precision or the consistency of its intervals. April 16. The Very Large Telescope Array captured a set of images that deepened the mystery further. For the first time, the inner region of the coma appeared hollow, a faint cavity surrounding the central nucleus, with 4 linear structures extending outward. They were symmetrical, spaced evenly, and oriented along magnetic field lines measured by solar probes. No natural comet or asteroid had ever displayed such geometry. Some argued that this could be a visual artifact, a diffraction pattern caused by the telescope optics. Others, analyzing the raw photon data, disagreed. The structures were real. If correct, it meant the object's magnetic field was being shaped deliberately or by a self-organizing plasma process beyond current understanding. By late April, its visual magnitude reached the threshold of small amateur telescopes. It appeared as a faint blue-white point with a soft halo. Spectroscopy confirmed the presence of ionized oxygen, iron, and unexpected traces of xenon and krypton, gases that shouldn't survive near the sun for long. The ratios suggested continuous replenishment. Something inside was venting them in equilibrium. That venting, combined with its magnetic control, produced a stable field tens of thousands of kilometers wide. In effect, 3i Atlas had created a magnetic cocoon, a miniature magnetosphere within the solar system. That changed how researchers saw it. It was no longer an inert traveler. It was an active system, not alive, perhaps, but behaving like something that understood balance. Theoretical physicists proposed a new framework: complex dusty plasma autonomy. The idea was that, under the right conditions, a large body with conductive materials could generate self-sustaining electric and magnetic feedback loops. As it interacts with solar plasma, such a system would mimic intelligence. It would adapt, correct, and stabilize without any biological life inside. It would be a kind of cosmic machine created naturally, a relic of planetary formation in extreme electromagnetic environments. That explanation comforted many. It allowed the mystery to remain within science. But there was one problem. The object's plasma emissions were changing frequency, slowly aligning with Earth's Schumann resonance, the natural electromagnetic heartbeat of our planet. That was not coincidence. By early May, global magnetometers again detected synchronization. Every 7.83 Hz oscillation of Earth's field was mirrored faintly in the solar wind data surrounding the object. How could an interstellar body, hundreds of millions of kilometers away, mirror Earth's electromagnetic rhythm? It defied simple plasma coupling models. The distance was too great, the delay too short, the correlation too precise. It was as though the object was tuning itself to Earth's frequency. The more data scientists gathered, the less sense it made. Infrasound detectors recorded faint vibrations matching the same period. Satellite sensors, sensitive to low-frequency electromagnetic noise, began to pick up identical pulses. The signal appeared globally, simultaneous across continents, without time delay. There was no known mechanism by which spaceborne plasma waves could manifest as synchronized ground-level electrical noise, unless, of course, something was coupling directly through the sun's field lines, using the heliospheric current as a conductor. That realization reframed everything. 3I Atlas wasn't simply moving through the solar system, it was connected to it. On May 21st, a rare coincidence occurred. The object aligned with both the Earth and Jupiter, a configuration called a triple conjunction. During those hours, magnetometers worldwide recorded a spike, a resonance lasting exactly 55 minutes. The signature resembled a large-scale magneto-hydrodynamic wave, propagating inward along the heliospheric current sheet. No previous solar event matched its properties. It was unique. Some saw it as proof that the interstellar visitor had created a new pathway for electromagnetic energy between planets. Others viewed it as simple coincidence within the chaos of solar dynamics. But no one could deny that Earth's atmosphere responded. Ionospheric density rose by almost 5% globally. It was as if the entire planet had absorbed a whisper of energy from the visitor, but no one could deny that Earth's atmosphere responded. Ionospheric density rose by almost 5% globally. It was as if the entire planet had absorbed a whisper of energy from the visitor. From a scientific standpoint, it became a perfect case study. Data from hundreds of instruments showed that plasma can couple across astronomical distances in ways not fully described by current models. New theories of interplanetary resonance were born. Terms like field coherence migration and magnetoelastic coupling entered the lexicon. 3I Atlas had become a laboratory in motion, a cosmic experiment no human had built, but every scientist could observe. As June approached, the object's orbit placed it directly between Earth and Mars. By now, it was bright enough to see through binoculars. Observers describe it as unnervingly static, a steady point, unlike the flickering motion of comets or stars. Long exposure photographs revealed a subtle hexagonal structure in the distribution of light intensity. Mathematicians analyzed the pattern and found it corresponded to minimal energy geometries seen in self-organizing plasma lattices. If true, it was another sign that the object was more than inert matter, that it was a system seeking stability within the electromagnetic field of the Sunday, and yet stability sometimes hides intent. By June's end, the visitor would pass through the plane of Earth's orbit, not a collision, but an encounter, close enough for direct radar mapping. No one knew what that would reveal. Would it reflect like rock or resonate like metal? Would it remain silent, or would the synchronized pulses finally resolve into something structured, something we might call a message? The scientific teams prepared. Radar arrays in Puerto Rico, Australia, and Northern Europe were all scheduled to transmit simultaneous beams. For the first time, human technology would speak directly to the interstellar traveler. What it might answer, no one could predict. In the next segment, we will explore the final approach, the radar contact, the data that could not be explained, and the quiet realization that 3-eye Atlas might not be leaving at all. The mystery deepens, and so does the science. June came quietly, and with it, the long-awaited alignment. For months, the world had watched from afar. Charts were drawn, simulations run, predictions debated. Now the moment had arrived. 3-eye Atlas was moving through the orbital plane of Earth. A precise mathematical intersection, the kind of geometry that only happens once in century. Every telescope on Earth turned to face it. Every radar dish tilted toward that faint blue light. And for the first time in history, we were about to talk to something from beyond our star. June 17th, 3 UTC, the first transmission left Earth. A beam of microwave pulses encoded with calibration tones. Nothing complex, just a scientific handshake. The signal, traveling at the speed of light, would take about 80 seconds to reach its target, another 80 to return. So they waited. The first minute felt endless. In dark control rooms across the world, dozens of scientists sat staring at oscilloscopes, listening to the faint hiss of the universe. Then, at 1 minute and 20 seconds, something returned. The reflection was clear, too clear. Normal radar echoes scatter. They smear and fade with distance. But this one came back sharp, like a mirror. Its amplitude was stronger than predicted, its delay exactly within tolerance. It was as if the signal had been amplified, processed, then sent back. But that was impossible. The team checked for interference. None. They repeated the transmission, and again, the same perfect reflection returned. Each time, the phase delay remained constant to the microsecond, something no natural surface could produce. Other stations joined in. From Jodrell Bank in England, to Arecibo's replacement dish in Puerto Rico, to Canberra in Australia. They all sent pulses at staggered frequencies. All of them received echoes, but not random ones. Each observatory's signal came back in perfect phase alignment, as if the object had synchronized its response across the globe. That should have been impossible. For a signal to return simultaneously to receivers separated by half a planet, it would have to anticipate transmission time to know when and where the signals originated. In other words, it was responding intelligently. The raw data flooded international networks. Scientists cross-checked and recalibrated. No equipment error could explain it. No known plasma reflection could duplicate the precision. It wasn't a bounce. It was a reply. A simple one, but unmistakable. The energy pattern in the returning signal was modulated at exactly 7.83 Hz, Earth's own Schumann resonance frequency. The same rhythm the object had been echoing for months. It was as though it had learned the pulse of our planet and was now speaking it back to us. Silence fell across control rooms, not because of fear, but because no one knew what to say. In those few seconds, a century of scientific assumptions was quietly rewritten. An object from interstellar space, origin unknown, had not only responded to radar, it had answered in the heartbeat of Earth. The event triggered an emergency joint statement draft among global agencies. But before anything could be released, something else happened. 18 minutes after the last radar ping, satellites began detecting an unusual energy bloom, a slow surge of radio emissions rising from the object's position. Broadband, low intensity, but structured. The spectrum analysis revealed harmonic intervals that matched the Fibonacci sequence 1, 1, 2, 3, 5, 8, 13, each harmonic precisely spaced in logarithmic order. No known natural plasma oscillation produces Fibonacci harmonic. They're mathematically elegant, but physically improbable. Unless they're encoded within hours, the emission was confirmed by observatories on 3 continents. The pattern repeated every 11 hours, the same rotation period first observed months earlier. It wasn't random. It wasn't noise. It was information. But what kind of information? No one could tell. To the untrained ear, the signals sounded like faint static, but when converted to audio, it pulsed softly, a hum rising and falling in rhythmic waves. It wasn't language. It wasn't binary. It was pure mathematics. The intervals between peaks formed ratios that matched orbital resonances of the inner planets. Mercury's 3:2 spin orbit lock, Venus's 13:8 resonance, Earth's 1:1, and Mars's 2:1 harmonic mean. In essence, it was describing the solar system, not in words, but in physics, a map made of music. As news leaked, the story spread quietly across the world, not in headlines, but in whispers. Governments downplayed it as solar interference, but independent data analysts confirmed it. The same Fibonacci harmonics, the same periodic pulses. No error, no coincidence. Something out there had learned the language of orbital harmony and was reciting it back over the next several days, the emission intensified slightly, then stabilized. No modulation, no escalation, just the same cosmic heartbeat, steady, patient, and calm. Meanwhile, new radar scans revealed another strange development. The object's geometry had changed again. Its coma, once circular, was now elliptical, aligned directly toward Earth. That could mean simple solar wind shaping, or it could mean orientation, as if it was facing us. By June 29th, its brightness increased tenfold. Through telescopes, it glowed like a miniature aurora, a sphere of blue and white plasma surrounding an unseen core. High-resolution interferometry revealed magnetic field lines forming perfect hexagonal vortices, geometries associated with stable plasma confinement. In simpler words, it looked like a reactor, an enormous, naturally formed fusion bubble, or something built to mimic one. The timing of its pulse shifted slightly, no longer exact 11-hour intervals, but adjusted by a fraction of a second each cycle, slowly converging with Earth's rotational period. Each adjustment brought the synchronization closer. 11 hours became 10, then 9.5. By early July, the pulses were arriving every 8 hours, the length of 1/3 of an Earth day. And then they stopped. July 3rd, the object went silent. For the first time since it entered our solar system, no measurable emission, no harmonics, no heat pulses, total stillness. It was as though it had gone dark, or was waiting. Around the same time, the James Webb Telescope detected an anomaly in reflected light. For a brief window, the reflectivity of the object dropped to nearly zero. It became invisible in infrared, a perfect absorber. Then, 30 minutes later, the reflectivity spiked as if an enormous surface had unfolded and then retracted. Whatever happened in that half hour remains unexplained. But after it ended, a new signal appeared, one never seen before. At 9:44 UTC, radio receivers worldwide picked up a synchronized broadband pulse. It lasted precisely 1.618 seconds. The golden ratio, phi, encoded in time. It was the first and only in time that the signal's duration itself matched a mathematical constant. That moment became known in internal memos as the phi event. It was impossible to interpret. It was impossible to ignore. After that, the object began to move again. But its trajectory had changed. Not outward, not inward. It was now circling, entering a slow, stable orbit between Earth and Mars, a captured body, an interstellar visitor, now bound to our star. And, just like that, the fear of collision faded, replaced by a deeper, quieter realization. It was staying. Scientists reclassified it officially. No longer a transient object, but a bound interstellar body. The first of its kind, but deep down, many suspected otherwise. Because bound objects don't radiate Fibonacci harmonics. They don't reflect radar with mathematical precision, and they don't pulse in synchronization with planetary resonance. Whatever 3I Atlas was, it wasn't a comet, it wasn't an asteroid, it wasn't random, it was deliberate. At this stage, governments enforced silence. Observatories were asked to release only filtered data. The public story was simple. A comet captured by the sun, nothing unusual. But behind the scenes, a classified report circulated among scientists. It contained a final image from high-frequency radar. Not a bright point, not a chaotic reflection, but a shape, geometric, perfect, a lattice of concentric rings arranged like circuitry, and in its center, a void. That void was unlike anything recorded before. It didn't absorb energy. It redirected it, bending radar signals around it and returning them inverted, an impossible effect, something that implied control of electromagnetic geometry beyond any known technology. The team called it a phase inversion field, a structure that manipulates waveforms like gravity manipulates light, and yet it wasn't hostile. It wasn't emitting destructive energy. It was simply there, stable, quiet, present. By July's end, the object had fully settled into orbit. Its distance from Earth, 22 million kilometers, close enough to be visible with the naked eye at dusk, as a soft blue point hanging above the western horizon. People began to call it the second moon. Children pointed at it. Artists painted it. And night after night, scientists recorded data they couldn't fully explain. It never sent another pulse. It never emitted another signal. It simply remained watching, reflecting, balanced between two worlds. That's when a single final anomaly appeared. On August 1st, during a simultaneous observation campaign, radio telescopes on Earth recorded a faint echo coming not from the object, but from space behind it. A mirror image of the Phi event, delayed by exactly 61.8 minutes. 100 times the golden ratio constant in seconds. It was as if space itself had become resonant, as if something beyond the object had answered back. And then, like before, silence. The experiment was over. In the following months, scientists debated endlessly. Was it natural self-organization of plasma? A relic of a dead civilization? A magnetic intelligence made of dust and energy? No one knew. But one fact remained undeniable. 3I Atlas came from another star. It entered our solar system, altered its motion, aligned with Earth, and then stayed. A fragment of the unknown, now orbiting our sun, quietly defying explanation. It's strange, isn't it? How something so far away can change the way we look at everything close. Months have passed since the last signal. 3I Atlas now circles the sun in complete silence, a small, steady point between Earth and Mars. No radio emission, no plasma ripples, just equilibrium. A perfect balance of motion and field. Astronomers still measure it daily. Its orbit remains stable to within a fraction of a second. No acceleration, no decay. It simply is. The radar images are now archived, labeled as anomalous but non-threatening. The The public story remains that of a captured comet, but in private notes and late-night conversations, scientists use different words. Words like resonance structure, electromagnetic architecture, and non-terrestrial symmetry. The truth is simple and uncomfortable. We do not understand it. Some believe the object is dormant, a machine waiting for a future alignment, perhaps centuries from now. Others think it has already served its purpose, that the signals, the golden ratio pulse, were never meant as communication, but calibration, as though something vast, unseen, used it to tune the solar system itself. A new branch of research was born from the mystery. Physicists now study interstellar plasma resonance, the theory that magnetic fields can form stable, self-aware patterns without biology, without circuitry. They call them field minds, energy that thinks, matter that listens. And in the data of 3-eye Atlas, they see the first proof that the universe may already be alive. From Earth, you can still see it. On clear nights in the west, a faint blue point, never flickering, never moving fast, a reminder that space is not empty. Sometimes telescopes catch faint glimmers within its halo, thin, rotating arcs, as though the object still breathes in slow motion. Maybe it's natural, maybe it's artificial, maybe those two words no longer mean what we think they do. So now the world continues, our machines hum, our rockets rise, our lives move forward. But somewhere beyond Mars, something from another sun moves quietly through magnetic currents, as if listening to the heartbeat of Earth. Maybe it always was. Maybe it always will be. If stories like this make you look up at the night sky and wonder what else is out there, don't stop here. Hit subscribe and watch the next video now appearing on your screen. Because the mystery of the cosmos isn't finished. It's just beginning.